Beauty isn't, I mean, it's the classic, right? Beauty is in the eye of the beholder. Beauty is how you feel about yourself, I think. I don't know. It's a really, really, it's funny with this. It's the first line of my book, and we all know what beauty is, and yet we can't define it. It's like age. What is age? But we all
Mhm.
know it when we see it,
Yeah.
like, right? I don't know because if you point to anything specifically, you can always find the opposite to be true as well.
Welcome to the Beauty Talk podcast, where we feature how the best medical practitioners help their patients to look better, younger, and healthier. Now, enjoy the show, and here's your host.
Daniel Gao here. I'm the host of Beauty Talk. We feature the top medical practitioners in health and beauty, both inside and out. I have Sandra Kaufmann, the author and creator of the Kaufmann Protocol, a systematic explanation of why we age on a cellular basis, coupled with an organized system to delay the aging process. This theory was introduced in the book, The Kaufmann Protocol, Why We Age and How to Stop It, which has been recognized by many longevity leaders as the go-to tome for understanding the aging process. She has more recently published the Kaufmann Protocol, Aging Solutions, with an updated and expanded dive into longevity science. Additionally, she began releasing a longevity treatise series of e-chapters, the first of which is Mastering the Mast Cell. So, Sandra, welcome and glad to have you here.
Oh, it's my absolute pleasure. Thank you for having me.
Yeah, so let's start from the very beginning. How did you first get interested in the medical field?
Oh gosh. So my dad's a physician, and I love biology. And to be perfectly honest, I was going to be a tropical ecologist.
Oh.
So I spent my undergraduate days in tropical forests, jungles, getting lost actually a few times, which was kind of fun. I have a master's in cell biology. It's actually plant physiology and cell biology. And then at some point during my master's, it was going to be a PhD, and I sort of truncated it to a master's. My father pointed out that plants don't really pay bills. And at some point, I was going to have to get a real job. So, he's like, if you go to med school, I will pay for it.
Mm.
So I did. So I did, regular med school. I did a year of neurosurgery. I did a year of general surgery, ended up as an anesthesiologist, got a fellowship in pediatric anesthesia, and then spent 20 years doing that.
Mm.
And the cool thing about what I call my liberal arts background in medicine is that you learn a lot about what drugs do to the body, what the body does to drugs, different pathologies, and then you watch people age and you start realizing that it's all one big sort of game and you can game the system and slow down aging.
Wow. Okay. Now, when you did the transition to longevity, was that kind of like just part of that natural cycle of kind of studying cells and then kind of went into that arena, or like what was it that led you to want to focus on longevity?
So I'm a bit of an amateur athlete. I'm
Mm.
certainly not an Olympian, and I know some Olympians, so I don't want to offend them by thinking that I'm anything great. Um, but I was a rock climber,
Mm.
serious rock climber,
Mm.
and I remember hanging off a cliff in my 40s. You're sort of sitting there, you're like 300 feet in the air, you're sort of like on a hanging belay. And I distinctly remember thinking, I got to do something about this aging business because this is for the birds, right? Just climbing doesn't go well as you get older. And I know some older climbers and they're like, it's fine, but in reality, it's not, right? It's a game of the youth.
Mm.
So I decided sort of then and there while hanging from this cliff that I was going to use my science background, my cell biology background, and my extra time, of which I don't have that much, but what I did have to sort of figure out from a cellular perspective why we age. And granted, it was, this was a long time ago. This is like, gosh, 12, 15 years ago. So there was no longevity medicine. There was no anti-aging. There was no biohacking.
Mm.
This was me plunging myself into the medical library, reading a gazillion articles and trying to sort out details into some semblance of sense.
Wow. Okay. And then, so that led you kind of down to this path. Now you're in longevity. So let's kind of start there. What causes people to age? Let's start with that question.
So I love that question. It's one of my favorite questions because depending on one's perspective, people look at organs, they look at systems, people look at, lifestyle choices. I like to look at cells. And because I was a cell biologist, so I'm a little bit biased. But
Mm.
I think that you age because your cells age, because we are made up of cells and cell products. And if you think of a cell as a little mini factory, And each of these factories can make up to 10,000 different proteins. When that factory starts to fail, you start to fail. And I took all of the various reasons and put them into 7 categories. I know people talk about the hallmarks of aging, and I think it's just this mishmash list of things that are not really correlated on various levels. So my thought was I have 7 big categories, and then I've got a lot of subcategories. So it's pretty detailed, and I'm happy to share it with you. Your audience is going to be like, oh my gosh, here comes the boring stuff.
Now let's start there.
Okay, so tenet 1 are things that go wrong with your DNA. So this would be epigenetic remodeling. And it's kind of the reason that identical twins look less and less identical as they get older, because what they eat, what they breathe, what they smoke, what they this, what they that affects the epigenetic modeling of your DNA, allowing you to either express or not express various proteins, and then it shapes your life. So that's epigenetics. And then of course there's telomere shortening. That's a big Bill Andrews conversation, right? Replicative stress and oxidative stress leading to cell failure. And then the last thing in this category is heterochromic distribution within the nucleus. So your DNA gets packed or unpacked. It's either heterochromatin or euchromatin. And as you age, these little pinchy things, HP1s that sort of keep your DNA together, you lose them. And it sort of starts to unravel. And so the control over what proteins you express fails. Anyway, so that in a nutshell is tenet 1, and that's DNA.
Okay. Now with the DNA part of it, it seemed like you were kind of implying that a lot of it is the nurture part, like nature versus nurture. Hey, this is your DNA, like you're kind of stuck with your DNA. You really can't change anything. But it did kind of sound like you mentioned with the twins example, that the nurture process, depending on how they live and what they do with their lives, can vastly affect the DNA. Is that kind of true?
So good question. So it depends how you define your DNA, right? If you just define it by your sequence of T, A, Cs, and Gs, and the spiraling helix, is defined by like Watson and Crick in the 50s, you can't change your genetic code. But what you can change is the epigenetics. And epigenetics, epi means on top of, right? So it's things that get glued onto your DNA that control which pieces and parts of your DNA you can use. Right. So I like to picture like your roll of DNA with little lollipop things sticking on there. And those are methyl groups. And the more methylation that you have, the less able you are to use that section of the DNA.
Mm-hmm.
In addition, your DNA is wrapped around histones. And I like to describe this as sort of like Christmas tree lights. So you'll have a string of DNA, 2 wraps around a cluster of histones, and another string. So you get, looks like Christmas tree lights. And histones get things glued onto them. They can get methylated, phosphorylated, all sorts of things. And the control of that then also dictates how much you can unroll your DNA and what you can get to, right? So it's the epigenetics that change, not the actual like DNA sequence.
Okay.
And epigenetics is super cool because not only can you change your own, right, but you can also inherit that of your great-grandparents.
Mm-hmm. Okay. So it seems that
So
even though you get your DNA from your parents, your grandparents, but there is a lot within your own control of that longevity and you controlling that aging process.
oh yeah, I know. It's actually there've been some really interesting studies about epigenetics. So as an example, during World War II, they looked at a bunch of pregnant women, you know, retrospectively. And some of the women were absolutely starving, and depending on what country they were in, and other, people were not starving. And it turns out that the great grandchildren of these people that were starving genetically became more likely to hold on to calories and glucose because they were starving, right?
Mm-hmm.
But as a consequence, their grandchildren are more likely to be obese and diabetic.
Interesting. Wow. Really, really
Right?
cool.
Isn't that cool? So
Yeah.
there's lots of sort of like, so you inherit some epigenetics, but you can also alter your epigenetics. So
Mm.
I think that's just insanely cool.
Yeah. Oh, that is. Okay. So we have the DNA. That's the first tenet. What's the second
Yep.
one?
So the second one is mitochondria.
Mm.
So this is everyone knows is the powerhouse of the cell. We picture the thing that looks like the kidney bean, the bilayer kidney bean, sort of sits there. And it creates energy, but it does lots of things. It creates calcium homeostasis. It controls whether your cell is going to die under certain conditions. It's called apoptosis control. Does many, many things.
Mhm.
But mitochondria fail for 7 to 8 reasons, depending on how you count them. And it's everything from oxidative stress to NAD deficiency to mitochondrial transposition or mitochondrial transition pore control. Has to do with sirtuin 3. And we'll get to sirtuins because they're sort of in the next category. But sirtuin 3, 4, and 5 control your mitochondria. 3 is the master regulator. So without it, you can't do much of anything.
Mm,
But the list goes on and on. Roughly, there's 7 things. Some of these are hard to fix, and some of them are very easy to fix.
mm. Okay. Okay. So you got that part. There's like the energy centers of the body, I guess you can call it.
Mhm.
Okay. And those kind of break down over time. Is that what causes aging?
It contributes to it. So
Mm,
the biggest, easiest example is NAD deficiency,
mm,
right? So
mhm,
nicotinamide adenine dinucleotide. Everyone's sort of obsessed now with their NAD infusions and injections and supplements, that sort of thing. And
mhm,
the reason that this is important is that you need it for about 4 different reactions within your mitochondria to make energy.
mhm.
So it's
Okay.
important in your mitochondria.
Mhm,
But it's also a cofactor for up to 500 different enzymes around the rest of your cell.
mhm,
The 2 big important subcategories are sirtuins, and we'll get to sirtuins. I keep referring to them. We're not there yet. And these are pathways that control all cellular homeostasis,
mhm.
and they need NAD as a cofactor. So if you don't have NAD, you'll lose cellular homeostasis, and that whole thing sort of goes awry.
Okay.
Um,
So is NAD kind of like fuel?
so NAD is it like fuel?
Okay.
Kind of like it's not
Mhm,
ATP.
mhm.
ATP is truly the energy processor. That's sort of like the Bitcoin of the cell.
Okay.
Um, NAD is just it's just a molecule that we need.
Okay.
Uh, and 2 things happen to it. Half of the time, a proton sort of gets glued on and off. It's just a shuttle system for protons, and that's what it does in the mitochondria.
Okay.
So it's recyclable.
Mhm,
But when you move down to the other uses for it, you actually break the molecule apart.
mhm.
And then for it's not as recyclable. It has to go through a bigger system to sort of get the pieces put back together so you can use them.
Okay.
Um, but the other really big thing that you need them for are something called PARPs. And
Mhm,
PARPs control DNA repair,
mhm,
essentially,
mhm,
right? So as you get older, you need more NAD, but you produce less,
mhm.
secondary to enzyme failure and a few other things.
Okay.
Anyway, so as you get older, your body has a limited amount of NAD, and it says, well, what am I going to do now? So you'll notice people have less energy. They're more likely to get cancer, and they're more likely to lose cellular homeostasis.
Mm,
So as a consequence, one of the easiest low-hanging fruits is to supplement NAD. And there's big, I wouldn't say wars, but there's big, concerns over like what's the best way to do it, when, where, how, why, which company, blah, blah, blah. But certainly there's significant evidence demonstrating that if you supplement your NAD levels, you're going to do better overall.
Okay, good to know. So that's the one place to be able to think about is NAD. How do you replace NAD, especially as you get older?
Mhm.
Okay, yeah. So let's move on to the next one then. You mentioned sirtuins. That's kind of like the next one. So let's bring
Next
that
one is
one up now.
sirtuins. Absolutely. So category 3 is called pathways. Right. And I always talk about the 7 sirtuins first. There's 7 mammalian sirtuins, so we mammals. And what they do is it's a gene that then gets translated into an enzyme, and they serve as on-off switches around your cells. And 1, 6, and 7 live in the nucleus. 3, 4, 5 live in the mitochondria. 2 sort of flits around the cell. We don't really know what it does exactly. But they do. They control things and basically turn them on and off. So 1 is the big one. It controls your circadian rhythms, right? So if you're not sleeping, people go, oh, you need turn off your blue light, blah, 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 blah. Like the reality is you're not sleeping because you're sirtuin deficient. It controls if you're going to make antioxidants, right? It's going to control how much PARP you create. It's going to control where you deposit your fat, right? This is one of my favorite ones actually. So people come to me all the time and they say, I'm getting a little older. I eat the same and I exercise the same. Why is my fat being deposited in my belly? Right? I call it the abdominal tire syndrome. And the answer is because sirtuin failure prevents you from putting fat where you should put it. You put it where you shouldn't put it. So if you turn your PARPs back on, then your fat distribution goes back to normal or to a youthful distribution.
Okay.
So 2 and 1 is very general. So 2 and 3, as we said, lives in the mitochondria and it controls how much energy you're going to have. So that's kind of important. And then so 2 and 6 lives in the nucleolus and it controls DNA repair. So you turn one on, which turns six on, which then fixes your DNA when you are sleeping in conjunction with your circadian rhythms. So it's all very, um, so that those are sirtuins.
Okay.
Other pathways here, we've got AMP kinase, which is a measure of how much energy your cells don't have. And when you are stressed for energy, your body goes into a state of hibernation, essentially, which is good for longevity.
Mhm.
There's the mTOR pathway, which is why rapamycin is popular. And then there's the circadian rhythms. And as I mentioned, like you don't not sleep because of bad sleep habits. Well, some people do. But as you get older, right, you fall asleep because you make two proteins. You wake up because you make two different proteins. It's controlled by two different proteins. And then there's an umbrella of things like NAD, sirtuin 6, and selenium, and a variety of other things that control the big picture. So
Mhm.
as you get older and all of these pieces and parts are failing, it's no wonder that people don't sleep.
Mm, okay. Okay. So we got the pathways then. So and that's
Pathway.
tenet three, I believe, right?
Yes,
Okay.
yes.
So
So four, at
Mhm.
this point, all of your listeners are like, oh my God, this is depressing. Um, so 10 and 4, I call quality control. And it sort of goes back to my factory model, right? Things are going to go wrong in your factory, either the instructions, the machinery, something, right? So this is basically DNA repair mechanisms and protein issues, right? So if you take a step back and you measure it, in every cell, every day, you have 10 to the fifth DNA errors. That's a lot,
Yeah.
right? It's a lot. And if you don't fix them, you're going to have cell failure or cancer or apoptosis or senescence or one of those horrible things. So
Mhm.
you have to repair it. And it takes a lot of energy. So if your mitochondria are down, it's not going to happen, right, as you get older. But there's
Mhm.
also 5 different DNA repair pathways.
Mhm.
And of course, they fail over time. Good news is, of course, you can fix a lot of these things.
Mhm.
So that's DNA. Secondly, there's a whole game of proteostasis, right? Proteins are very expensive to make for your cells. And as I said, your cell can make about 10,000 of them. And as you get older, the processes of keeping them intact sort of fails.
Mhm.
So you want to be able to regulate your chaperones. And there's a variety of mechanisms to do that. So proteostasis is a big deal. And
Mhm.
then lastly, in this category, when you have all of these pieces and parts that you can't fix, you recycle them. And that's called autophagy. So I put autophagy in this category.
Okay. Got it. Okay. So you have those pieces. And then the next tenant. What's the next tenant?
The next tenet is your immune system that becomes your inflammatory system,
Mhm.
right? And we are so inflamed over time, it's called inflammaging,
Mhm.
right? And you can measure, people can measure their high sensitive CRPs, your IL-1s, your IL-6s, your sed rate. We know, of course, that people get inflamed. And some of it comes from fat, some of it comes from, like innumerable different reasons.
Mhm.
But we are inflamed over time. Um, and at the same time, your immune system that's supposed to save you from things fails,
Mhm.
right? So you don't respond as well to vaccines. You don't respond as well to, foreign pathogens, that sort of thing. Additionally, there's some cells in your immune system that become hyperactivated. Some fail and some get stimulated. So as an example of that, there's mast cells, and I just wrote a big treatise on it. Mast cells, you get an increase about 40% as you get older. And when mast cells, they carry lots of little granules of sort of pseudotoxic agents. And when they break open or degranulate, they not only, sorry, release histamine and some serotonin and a variety of other things, but they release a lot of proteases. So
Mhm.
they basically dissolve you from the inside out as you get older.
Wow. Doesn't
So
sound pretty.
no, it's pretty sore. So I hate giving the speech because it just sounds like death and destruction.
Mhm.
Um, and I'd like to remind listeners that like there's fixes for all of these things. Like it sounds terrible, but you got to start from somewhere so we can back it up.
Yeah.
Um,
Now, when it comes to the inflammation part of it, I want to kind of bring that to the surface because when it comes to inflammation, for people who just don't understand, like where does this inflammation, this inflammaging also like where does it come from? Is it just as I get older, this is just going to happen regardless, or is it like, hey, if I work out, I've heard that if I work out, I have inflammation in my body, so am I trying to avoid that? Or hey, if it's like, if I eat certain foods, is that going to cause inflammation? If I smoke or do drugs or do this or do that, like what is like those main things that's causing this inflammation kind of in a negative sense?
Excellent question. And it is sort of like this giant nebulous cloud of like, what the hell is it, right?
Mhm.
So some inflammation is quite good. It's designed so that if your body has a foreign attack, it's a pathogen, a virus, a contaminant, it will go and get rid of it, right? So it sends out chemicals to number one, destroy whatever it was that's attacking you, right? And then sort of remodel your tissue to get rid of whatever the remnants are. So there's a lot of agents that dissolve your tissues, and then they send out flares that go all over your body that says, send us help here. We need macrophages. We need this. We need that. So the system is designed to save you from danger. Unfortunately, it becomes hyper reactive or less controlled as you get older. So you tend to have, so if you had the same infection as a kid, as an adult, your immune system just blows up. So rather than releasing a few histamine or a few mast cells, you're going to have a ton of mast cells. Mast cells release inflammatory factors, i.e., you're inflamed. Fat releases a lot of inflammatory cytokinins. You get fatter as you get older because of homeostasis issues from sirtuins, as well as a variety of other problems. That causes inflammation. Oxidative stress causes inflammation, right? It's not just the oxygen that we're breathing, but here's an interesting one. Iron is toxic to us, and everyone takes iron supplements, which is like the worst thing that you can possibly do, as long as you're like not, if you're hemodynamically stable, don't ever take iron, because iron goes back and forth between +2 and +3. So it loses an electron, and the electron goes to oxygen. And oxygen that has radicalized is extraordinarily bad for us, causes massive inflammatory problems. Anyway, so inflammation comes from many, many, many places, triggers a whole lot of negative consequences, destroys proteins, destroys your DNA, essentially can cause cancer.
Wow. Okay. Okay. So this all falls under the immunity, I guess, the immunity tenet, right?
Correct.
Okay. What's the next one? I think we're on number 6 now, right?
Yeah. So six, yes, you're doing very well at keeping straight, because sometimes I get mess it up. So six is what I call individual cell requirements. And this is the idea that not all cells are created equal, right? Your senescent cells you want to get rid of.
What are
Your
senescent cells?
What are senescent cells? Senescent cells, I call them grumpy old man cells. Other people like to call them zombie cells. But I think that you'll see that why I like grumpy old man cells better. See, so once upon a time, there was a normal cell, and it had this DNA damage that we talked about, right? And the cell says, aha, I can fix this. So it shuts the cell down and goes into a state of quiescence, meaning it's just resting, and it turns on all of its DNA repair mechanisms. Okay. If that succeeds and it fixes it, the cell wakes up and goes back to being a normal cell. If the cell cannot fix it and has a lot of DNA damage, there are three options. Option one is the cell says, man, we are beyond help. We're just going to commit cell suicide. And that's apoptosis. It's just, and it's gone. I call it politely leaving, right? It can become cancer, and that's pretty horrible. Or it becomes senescent. And this senescent cell, the morphology changes. So rather than being a lovely round or ovalish type cell, it gets very globular, sort of like fat and messy. All the lipid membranes inside get a little distorted. And it doesn't do what it's supposed to do. It doesn't make the proteins it's supposed to make. Instead, what it does is it releases something called the SASP, which essentially is just a boatload of inflammatory factors, i.e. more inflammation as you get older. And the thing about these inflammatory factors is then they go to the cell next door in a paracrine fraction, and they make that cell become senescent. So all of a sudden, you've got this giant wad of senescent cells releasing inflammatory factors, causing more damage all over your body. So the reason that this is a grumpy old man is I always picture the guy who's been at the factory for like a million years, right? At one point, he was young, enthusiastic. He was doing his job. Over time, he ate too many donuts. Now he's sitting in the cafeteria, like in the back. He's kind of this giant heifer of a guy, and he is grumpy. So anyone that come near him, he's just going to be like negative and exude negativity and like create more negative people and not ever really do his job. So he just becomes toxic over time.
Okay.
That is a senescent cell.
Okay, got it. So next question, how do you get rid of these senescent cells?
So excellent question. So there's a bunch of protocols. There's a few agents that we think can sort of do it. So the quercetin can sort of do it. Generally, it's just in combination with a chemotherapy drug called denacetab. Fisetin can sometimes do it. And then there's a few random drugs that can do it. So there's an antibiotic called roxythromycin that can help. Um, Trying to think. I think there's one more. I can't remember it offhand.
Mhm.
But what you end up doing is you do a high dose of any of these, either together or in sequence. Um, and then you like do it every other month because you don't want to all of a sudden get rid of all of your senescent cells,
Mhm.
depending on how old you are.
Mhm.
A few scientists and I have this running joke that if you're really old and you got rid of all of your senescent cells, you would just go poof, and you'd be like, a pile of sand. So the idea is you want to get rid of some of them and then wait for them to be replaced by normal cells and then do it again. The
Okay.
other idea is that not all senescent cells are the same because they came from different cells originally. So it may take different types of agents to get rid of different subtypes. So I usually rotate my anti-senescent therapies.
Okay. Got it. Okay. So that's number six. Now, what's the last tenant?
So last testament is waste management, right? Back to the factory model, you got to take out the trash.
Mhm.
So this is mostly glycation issues and lipofuscin accumulation.
Mhm.
Lipofuscin accumulation is simply when a cell tries to recycle things, under the autophagy, what it does, it'll take some sort of cell piece, put it in a liposome, I'm sorry, a lysosome, and dissolve it, and then take out the things that it can reuse. But there's always a glob that you can't get rid of.
Mhm.
And
Mhm.
the cell doesn't really know what to do with it. Um, for cells that are going to like divide, sometimes it'll take it and divide it in half and just so that you just keep sort of like passing it on to the next cell. But for cells that don't divide, especially brain cells, it just keeps accumulating in the back of the cell.
Mhm.
I call this the kitchen drawer phenomenon
Mhm.
because in everyone's kitchen, and tell me if I'm wrong, there's a drawer that has all the junk in it that you don't know what to do with,
Mhm.
right?
Yeah.
That's lipofuscin. You can't really get rid of it. You kind of can, but not really. No one does. You keep it, takes up space, and ultimately it's just gonna like fill up your kitchen. So that's lipofuscin. But back to glycation, because that's the big one in this category. Glucose, but more specifically, sort of reducing sugars. So it's also fructose and ribose and a variety of other ones, are very sticky as molecules. And these things cause something called AGEs, advanced glycation end products, and these stick to your innards, right? So they stick to they stick to collagen, they stick to proteins, they stick to DNA, and they cause significant cellular damage.
Mhm.
Um, One of my fun examples is like at least in your skin, you have lots of collagen molecules sort of like holding it together, right? And I always envision like a cloth napkin. Okay. And if you take a cloth napkin, you can slide it because the collagen fibers and the linen fibers slide. But if you take a glob of super glue and you stick it on the linen napkin and you let it dry, all of a sudden when you pull it, number one, it doesn't pull very well. And number two, it breaks the fibers.
Mhm.
So if you take an AGE and you stick it on your collagen in your skin, in your bone, wherever your collagen is, and then you try to move it, you'll see that your skin becomes broken, which is why it sags.
Mhm.
Your bones become brittle, and you become more fragile over time. So AGEs are terrible.
So avoid sugar.
So you can avoid sugar, or there are ways to sort of cheat the system to sort of minimize the negative effects of sugar. But yes.
Okay, got it. Okay, so we have these seven tenants. And so when it comes to all of this that causes aging, I want to dive deeper into okay, what happens when you start trying to fix this, when you start trying to uh, age gracefully or try and age backwards, as kind of people have talked about. But there is this difference between lifespan, like how long you're going to live, and health span, like how many good years you're going to have. So is it kind of just assume that if you're going to live longer, you're going to be healthier? Or is there really kind of a difference between, hey, you can live a long time, but maybe the last 20, 30 years of your life may not be very healthy or very good?
Good question. So I think that in today's model of standard medicine, what you're talking about is more years of being miserable.
Mm-hmm. Mm-hmm.
I think when you think about longevity medicine, we think about increasing your health span, and then by default, you're going to be increasing your lifespan.
Mm-hmm.
And I'll tell you why. So I define healthcare in today's world by three tiers. Okay. Tier one is what generic medicine is right now.
Mhm.
And I'm equally as guilty in some regard because I am a physician, right? And we wait until someone has a medical problem.
Mhm.
You have appendicitis, you get high blood pressure, you get cancer, whatever it is. And you go to your physician and they treat you. But it's not proactive, it's retroactive, right?
Yeah.
So that's tier one, and that's very typical. Tier two is more of the functional medicine people. And they say, you should really exercise. You should really eat a little bit better. We're going to test you for Lyme disease and arsenic toxicity and blah, blah, blah.
Mhm.
Fantastic. But longevity medicine is different. Longevity medicine is tier three,
Mhm.
right? And this says that we know per my tenants and other people's information that aging is coming and cellular dysfunction is coming.
Mhm.
So if you can prophylax against those things, you are going to reduce all-cause morbidity, so all-cause disease, as well as all-cause mortality,
Wow. Okay.
right?
Well, yeah. Now, this I'm sure ties into your Kaufmann protocol, which I'm sure is like basically what do people do? Like we talked about,
What
like
do we do?
talked about the tenants. It's like okay, this is what causes aging, but what's the solution? Like, what can people do? What can they think about? What can they consider if they want to live longer and not only live longer but also live healthier lives as well?
Sure. So what I do for people is we build longevity pyramids, right? And this is based on the silly food group thing that we all learned about in the fifth grade, right?
Mhm.
Where in the bottom are things you should do a lot, and at the top are things that you only do a little bit.
Mhm.
So, right? So based on this pyramid, there are things that you have to do every day.
Mhm.
So there's diet, there's exercise, there's supplements, there's medications, there's light therapies, there's the cold plunges, et cetera, right? And then there's things you do every week. And as an example of this, I always use like full body massage. And everyone goes, ooh, I can do that, right?
Mhm.
And the idea is you're increasing blood flow to skin, to muscle, causing relaxation, lowering cortical, stress hormones, et cetera. So it's incredibly good for you,
Mhm.
right? And then going up the chain, like every month to quarterly, I think that people should use exosome therapies.
Okay, for people who
So
don't know, what is exosomes?
So exosomes. So exosomes are cell products. They're not cells, they are cell products. They are secreted by cells and they carry messages. And my generic explanation is that from one cell to another, it can either send a message, like a molecule of something like histamine or whatever, or a package of molecules. And if you're going to put it in a package of or put molecules in a package, because it's a biological thing, it's going to be round. So these are round bodies with messages inside. And the question is, what are those messages? Right?
Mhm.
And that depends on the cell from which it is coming and the cell to which it was intended. So
Mhm.
you can get exosomes from any types of cells. You can get them from adult tissues, you can get them from, platelet derived, but the best ones I think are perifetal. So we get them from not baby tissues, but around the baby. So placenta or cord, Wharton's jelly, amniotic fluid.
Mhm.
And these are messages that came from babyish cells, so mesenchymal stem cells from perifetal tissues, and they send out messages that would have gone to a baby to tell it to grow healthily, regenerate, anti-inflammatory messages, amazing growth hormone type stuff. It's mostly microRNAs, microRNAs and transfer RNAs and that sort of thing. But anyway, so if you get these exosomes, which are not cells again, they are cell products, and you inject them into a person, wherever you put them, you tend to rejuvenate tissue.
Mhm. Okay.
So you can put it locally in your face and your skin looks amazing. You can put it in your scalp and your hair grows back. I can put them in shoulders. I can put them in knees. I can make tissues be better. Or if you just want general longevity, it's an IV and it goes pretty much everywhere in your bloodstream.
Mhm. Got it. Okay. So
That's
that's
an
part of kind of like that next chain exosome treatments. So what else? It kind of within this
So
chain.
when you go higher than that, then you're talking plasmapheresis, and higher than that, you'd say maybe stem cell therapies, but I'm not a huge fan. And then there's other things that were sort of like really kind of esoteric. But for most normal people, you sort of focus on things that you do every day. Diet, exercise, supplements, and medications, and then whatever. And then you can also supplement with some peptides that I think are important, but not, they sort of fill very important gaps. Like if you have a problem, you can use it, but they're not pure longevity.
Okay. Okay.
So, so in terms of longevity supplements, the next question therefore is like, what do you take?
Yeah.
And this was my big question when I did all this. And so what I decided to do was rate all of these supplements and all of the 7 tenets. And this is my rating system. It is designed to help people understand what they do or what we know about them, right?
Mm-hmm.
So I would look at, for example, tenet 1 DNA. If agent X, whatever it was, did something in the DNA in a test tube, a culture, whatever, it got a 1. If it has evidence that it did something in a non-human mammal, it got a 2. And if it had very clear evidence that it was very helpful in humans, it would get a 3. But if you did nothing, I got a 0. So it's basically the options are 0, 1, 2, 3.
Okay.
And if you did that in each of the 7 categories, then each agent then comes with a 7-digit rating number, right? And
Yeah.
it basically demonstrates that if you're trying to nip aging in the bud and you want to hit all of the categories, you want to pick agents that sort of make sure you have points in each of the categories. So it becomes a sort of like numerical algorithm instead of a guessing game.
Okay. And with this scoring system, is it very specific to, hey, we have this one supplement and it has a score and it's be good for everybody? Or is it kind of part of the process where it's like, hey, we're going to look at you individually, and based on how you individually are responding, we're going to recommend this one, this one, this one, then this supplement because it responds well with you individually?
Good question. So what basically all the evidence, I mean, we haven't done a million lab studies on you and how this affects you. So we're extrapolating from other people, is it going to have the same numerical rating system in you? And the answer is yes. However, everyone's constitution, of course, is different. So we look at their labs, we look at their family history. If everyone in your family has diabetes and you're pre-diabetic, you're going to have waste management issues, right? Therefore, I'm going to pick a lot of agents that have high points in tenet 7.
Okay. Okay.
Right.
Yeah.
So it's the other way around. So I'm going to tailor your protocol based on what I think your cell failure is going to have.
Interesting.
Right.
Okay. Yeah.
So here's an example. If everyone in your family has the same cancer, it's probably a genetic mutation somewhere like specifically that everyone has. I can't fix that. Right. But if everyone in your family has a different cancer, you probably have a DNA repair mechanism problem. And that I can't fix it necessarily, but I can make it significantly better and lower relative risk of cancer.
Okay. Now, are there any supplements just kind of across the board that you would recommend for the vast majority of the population?
So most of it's age dependent, right? You don't want to be giving longevity stuff to people if they don't need it. So But there are some things that everyone would probably benefit from. I'm famous for saying my favorite molecule, because everyone needs a favorite molecule, is astaxanthin. Astaxanthin is one of the strongest free radical scavengers we have. It comes from algae. When algae gets angry, meaning it's physiologically stressed, it creates this orangish pinkish goo to protect its own cell parts and DNA. Right. And this algae, when it's angry, gets eaten by all of these things in the marine system. So anything that you see it's pink has eaten astaxanthin. So krill, shrimp, the eyes in quail, pink flamingos, that's all astaxanthin. Salmon, sockeye salmon, it's all astaxanthin. So if you consume the same molecule, it too will protect your DNA. So what's kind of cool, so when you take this, number one, your skin burns significantly less when you're in the sun. So that's kind of cool.
Yeah.
So, right. 2, it helps your vision. So that's kind of cool. 3, it's lipid soluble. So it travels around your body in your LDLs and your HDLs. And it's because it's a free radical scavenger, it causes those particles to not be oxidized. Thus reducing relative risk of cardiovascular disease. So amazingly good things with astaxanthin.
Got it. Okay. Now, I mean, when it comes to the future, like, where do you think the future of longevity is going?
Oh gosh. You know, it's funny, when I started this, like people would look at me like, what the hell are you doing? This makes no sense. Like I'm Don Quixote chasing the windmills. Um, it's gotten to be huge, big business, and there's now tons of research being poured into this. The supplement companies are insane, and everyone will tell you that theirs is the absolute best. So it's really kind of hard to figure that out.
Mhm.
But when you look at real hardcore science, we are making absolute strides in understanding how to control cells, how to get them to be younger. I think ultimately all of this is going to lead to significantly healthier people for significantly longer periods of time.
Okay. Well, that's good. I mean, I think the explosion in the interest of it has been a really good thing. And I think it's fueling a lot of the science behind it as well to get it kind of out there and in front of people. Because I think when it comes to healthcare, especially in the US, it's almost like kind of like you mentioned, it's you wait till someone is sick and then you start treating the problem. But if people are taking responsibility up front and trying to look for ways to stay healthier and take it into their own hands, then I feel like it's going in a better direction. Like people can take their health in their own hands, so to speak.
Yeah, no, I think so. And it's funny, people sort of like bitch and moan about, well, I have to pay for all of these supplements or medications or whatever it is. And I like to think of it as an insurance plan.
Mhm. Okay. Good way of putting it. Okay. So Sandra, is there anything that we did not talk about that we should have talked about?
Um, we covered a lot. I
Mhm.
think that the other, it's funny, years ago when I started doing podcasts, my first thing was always to sort of cross people's minds that longevity was real.
Mhm.
Because it was like people were doing voodoo and crystals, and like it was like my main point was like, this is real. But
Mhm.
it's funny now, people go, yeah, this is real, we believe you. So but I think now people are obsessed about natural versus not natural, and how they're going, what they're willing to put in their bodies, et cetera. And one of my take home messages has always been, molecules are molecules. And I don't actually care if it was in a plant or if it was invented in a lab yesterday. Like, if it's efficacious and if we understand risks and benefits, um, who cares? Right?
Mhm.
All things natural are not good for you, and all things synthetic are not bad for you. So I ask people to have an open mind in terms of what they decide to use, as long as they understand risks and benefits and what they're trying to what their goal is.
Awesome. Okay. Well, Sandra, I do have one last question for you, but before I ask it, I do want to point people to your website at kaufmannlongevity.com. Now, last question for you. What does beauty mean to you?
Ooh, that's a really good question. That is a really good question. Beauty isn't, I mean, it's the classic, right? Beauty is in the eye of the beholder. Beauty is how you feel about yourself, I think.
Hmm.
I don't know. It's a it's funny with this. It's the first line of my book, and we all know what beauty is, and yet we can't define it. It's like age. What is age? But we all
Mhm.
know it when we see it,
Yeah.
right? I don't know, because if you point to anything specifically, you can always find the opposite to be true as well. So I don't know. I wish I had a better answer for you.
Well, might be something for you to you probably be thinking about for a little while then.
I think I will. I will be at 3 o'clock in the morning. I'll be obsessing, and I'll call you with the answer.
Okay. Well, Sandra, thank you for coming on. Thank you for sharing your expertise. So, if people want to learn more, kind of about what you do, more about how they can uh, benefit from longevity, better lifespan, and health span, like where can they learn more about you?
So the protocol is on a website called kaufmannprotocol.com, but my particular sort of medical practice is Kaufmann Longevity. And then there's three things that people can read. So there's two Kaufmann Protocol books, and it talks about the rating systems and why you age and all the supplements, et cetera. And my first treatise on mast cells just came out a few weeks ago as well. Um, I decided that it takes so long to write a book that I was just going to release chapters. Um, so this was chapter one. I'm working on chapter two now, but at least it's out there so people can stop bugging me to get information out there. Anyway, there's information everywhere. And then I guess on Instagram, it's Kaufmann Longevity. And I think that's about it.
Okay, awesome. Well, Sandra, thank you again for coming on. Thank you for sharing your knowledge and thanks for sharing your expertise.
Oh, my pleasure. So much fun. Thank you for having me.
Thanks for listening to the Beauty Talk podcast. Any questions, please contact the practice directly with the contact information provided during the show. We'll see you again next time. Bye for now.